We also saw common other coordinate geometry formula, the gradient and the equation through 2 points. Now these things have, again, the inputs x1, y1, x2, y2. So we can actually add the file we just created. So what we want to do, and assuming we're just back on this calculator page, what we want to do is actually add to our coordinate geometry page. So we need to actually open it. And again, just like your home computer, if you go to the home page, you want to go to My Documents, and then go to your library folder, my lib folder, and then there's your coordinate geometry file. So we're going to open that. I don't think we particularly want to save what I just created. So there it is, there's my coordinate geometry file. Now I want to add more definitions to it. So, like before, I'm going to go Menu, Actions, Library, and then define libhub. Now I want to make an equation, so a command, which will give me the gradient between 2 points. So let's call it grad, and again, x1, y1, x2, oops, no, y2 equals, and then good old y2 minus y1 over x2 minus x1. Alrighty. Now I'm going to save this. So you know, I do the shortcut Control S, or pressing Doc, File, Save. All right. Again, I need to refresh my library. And in doing so now, when I go to coordinate geometry, I have my grad command there appearing. So you might be thinking, why not just create a separate file for UDF? Why do I need to open up what I just made? Why do I need to go back to this coordinate geometry file? Well, what I think is particularly powerful about saving UDFs of a similar ilk in the same file is that we see that if you have anything to do with coordinate geometry, anything at all, then all of your commands relating coordinate geometry can be found in the one place. Any command relating to vectors can be found in the one place. Any command relating to complex numbers can be found in the one place when you make it. So by putting all your relevant commands in the one file, it's more of a bookkeeping thing for you to save time when looking for it. Now, I'd also advise you, as you make your commands, and this is probably more relevant to the VCE students, as you make your commands, it's worthwhile noting in your bound reference the commands you actually make, what the inputs are, and how to input them. So for example, I'd be writing this distance command in my bound reference, and then just making note of what the inputs mean, and then how to actually input them. Because you might actually forget how your commands work after 6 or 7 months when it comes to exam time. Okay. Now, whilst these formulas may seem pretty trivial, and you're probably thinking, oh, well, this is just U9 and 10 work. Well, what else can there possibly be? Well, in methods, some common, and for those who aren't familiar with the VCE system, methods is kind of your pre-university calculus course. So in methods, there are some things we want to do quite often. So sometimes we want to find the x-intercepts, the y-intercepts. We care about the domain of a function. We care about the stationary points. We care about the absolute maximum, the absolute minimum. We might be interested in finding the inverse equation. So what we can actually do is create a very powerful command, customizable command that is, which actually spits out all this key information. So what I've done here, up the top here, I've just defined some random function that can be changed. I'll speak more about this in a later video. But this command here, even though it's taking up a lot of real estate on the screen here, In a matrix, we can actually create a command whose input is a function and spits out your x-intercept, your y-intercept, your domain of your function, all your stationary points of a function, your maximum value for your function, your minimum value for your function, your inverse of a function if it exists. So for example, the one up the top there, that basic quadratic, if I put info f of x, then straight away I get all my intercepts. I get my stationary points, which I may need to just move a little bit to the right there. Here we go. So maximums, I get my absolute minimum, and I get the equations of my inverses. That stuff's, I'll talk about stuff later on. But certainly, if we had that predefined in our CAS, then when you walk into a SAC or an exam with that in your CAS ready to go, you can knock off a substantial number of marks without having to do any substantive work, which is incredibly powerful. For our specialist friends, and again, for those of you who are not in the VCA system, specialists are sort of your slight extension of methods, and it's somewhat of a borderline first year university course in mathematics. So this is something I created earlier on in the year. So this is my vectors UDF page, which has all my predefined commands for vectors. So first up, I've got angle between two vectors, scalar resolute, vector resolute, and then determining if three vectors are linearly dependent or not. You're probably thinking, why have I done all this? Well, it comes back to the idea that whilst the CAS has a lot of predefined commands, right? So if I think about vectors, it might have unit vector. There it is. It's got a lot of stuff going on here, but it doesn't have everything. So for example, in specialist, some classic questions, particularly in exam 2 multiple choice, would be, here's some scalar resolute, or here's a vector resolute. And either find me the vector resolute, or given the vector resolute, find out this particular value. So if we can program and create our own command that actually computes the vector resolute, that can save so much time and so many keystrokes in an assessment. And by keystrokes, if we think, but what I mean by that is, so going back to the example of the distance between 2 points. So beforehand, if I want to find the distance between 1, 2, 3, 4, I'd have to manually type in square root. What have we got? 3 minus 1, whoops, all squared, whoops, plus 4 minus 2, all squared. I have to type all that in to get my answer. But by having a UDF at hand, with fewer keystrokes, I get the same answer and I save so much time. So that's some of the more powerful, I guess, consequences of UDFs. So hopefully this video has enlightened you to the affordances of the CAS calculator. I'll say, just as a final comment, when saving your UDF files, so if I want to save as, we're not allowed to have any spaces in the name. So if you want a space, then you might be better off putting in an underscore. And to put in an underscore, that'll be control spacebar. Okay. If you put it in a space, such as this, and save it, it will never appear in your catalog. Okay, so please try to be cognizant about that fact, and don't have any spaces in your file name. Okay. If you have any questions, please feel free to comment on the video, and thank you for listening.